So today I'm going to talk about the rendering in Dragonfly in both 3D and 2D. You see a image dataset loaded here, which I used very often. See the credit of the data. We know all the images are saved on computer as a grid. In a sense, it's based on the voxels. So every voxel has an intensity. For C, it's it's a like indication of the density, the coefficient for X-ray, right? The attenuation coefficient for X-ray. When we render or view the images, for example, we start with 2D. When we render the 2D images, we have a control which is called window leveling here. I pull out the panel to make it more clear. So you see, we call it window leveling because we can set up a window here, which is the yellow bars. And this window will show us which range of the intensity to render on screen. Like everything below the left bar will be black. You see here, every pixel with intensity higher than the right yellow bar will be white. So by changing this window, we can change essentially the brightness and the contrast. So if we make the windows narrow, we'll see high contrast. And also, it's not only the window; it's also we have the opacity here and the color. So let's say we have three elements. One is the range, which is set up by the window. One is the color, which is configured or decided by the lookup table. So when we change the lookup table, we will see different colors. Yeah, that's one color for one intensity. Every pixel or voxel with same intensity will be rendered with the same color. But we could change the color to use all these lookup tables. They are preset of the colors. And how we apply the color to the image, there are two different ways. So that's we call color mapping. One is the first one by default. The first one is we map the color for the full range. You see here, this is the intensity histogram. So you see the full range of the data. For this data, the full range is from intensity 0 to 3000. Why I have such a big number? Plotted range. So this is a plotted range. This is the range of the okay, just 1 second. Okay, because I used a custom unit for this. This is a bit confusing. I should use intensity as the, oh yeah. Well, this is another topic. I'm sorry, I didn't expect this. This is another topic, which is pretty confusing here. We could give a custom unit to the intensity. But in this case, well, I don't need to do this now, so I choose the density as unit, which is not a real unit. We just see the raw intensity, the grayscale intensity. Sometimes, for example, if we use a distance map or a volume thickness map, then the intensity has some other meanings. The volume thickness map, the intensity is a measurement of a distance, the volume thickness. So in that case, the density may have some volume, some unit, like a meter or a millimeter. But now I reset this unit to be density, which has no real unit. It's just a grayscale level. So now you see the full range is from 0 to 23,003, which is the maximum intensity of grayscale level in this data set. So I go back here. Now we see if we choose the first color mapping mode, the color will be mapped here. You see the control point of the color. It's mapped in the full range. If we select the second mode, you see the color control points changed. So the color is mapping only to the range we select, which means when we change the range, the bars, the colors, the control points of the colors will change at the same time. Both have their own like purposes. The first one, the color doesn't change with the window, with the bars. You see, when I change my window, it doesn't change the color, which means for the intensity, for a certain intensity, the color never changes. We only change how we see it. If we because for the opacity, we're using the first one. The first one is, you see the it's a straight line here, which means the opacity is the same for everywhere. So it's the same opacity for all intensities. So in this case, when I change the window, nothing changed because the color doesn't change, the opacity doesn't change. But if I use the second opacity, now you see this curve, now it's a straight line. That means the opacity, so everything below the left bar have 0 opacity, which is here. And everything above the right bar has the full opacity. And everything between has a linear, linear intensity, depending opacity, depending on the intensity itself. So now we can see the change, but the change now is not the color, it's the opacity. We see it or we don't see it. But if we change if we change it to the second color mapping and we use the full opacity, now you can see when I change my bar, my window, the color change itself, because now the color does not depend on the intensity only. It also depends on what the intensity relatively in this window, because the colors changed with my window. So we have seen actually 3 elements already: the range, the color, and the opacity. Opacity has different modes, like the full opacity, the linear opacity, and the third one is like custom, the piecewise. So you can specify or you can change how you want to see each color. So we have to notice the control point for opacity is independent to the control points of the colors, which means I can change. This is the opacity control point. I can drag to anywhere I want, so I can make it non-linear. I can also use my keyboard. If I press Shift key and double click, it will delete. If I press Shift key and double click one control point, it will delete them. If I press Control key and double click, it will add a new control point. And you can also split this. So for each control point, you see the alpha. Alpha is for opacity. So alpha is the measurement or the set for the opacity level. So you can either specify your alpha value, or you can just drag it up and down, up or down to change the value here. For the color, it's the same. If you click the color point, control point, you can see the color. You can change the color by click here. You can change it to any other colors. And you can also delete by press a shift key. And you can drag it relative to the position. So you see the positions here. Position normalized is the position in the range. Like for example, this control point is 0.229, so it's about 30% from the beginning. So from the left bar, it moved 30%, 23% of the range, which is here. So when you move it higher, this will be higher. And then this physical position is the position in the histogram, which is the intensity. So which means for this intensity, we render it with this color. Okay, now let's answer one question: why the background is black? Because every pixel in the picture, in the image, it has an intensity, even it's outside of the specimen. Because when we do CT scan, normally the field of view is a cylinder. Like so every pixel outside the cylinder will be, it's not even air, it's just blank. But we're not able to save like blank, like not a number for in the image file, in the grid. We give the back everything outside a zero intensity. So that's why we have a lot of zero intensities here. And because of the setting of this opacity, everything below is black, but it has intensity. It has a full opacity. When we use the first one, it just pure black. So if we don't want to see the black, we could use the second one. You see now, everything here is not black. It's still black, but because of because the opacity is zero, so we don't see it now. If you want, of course, if you want to render it to another color, it's possible. If you want to just change the color control point for the left bar, by default, or for many lookup tables, it's black. If you want to change it to, for example, white, you see now immediately everything below is white. Right. But of course, it's not a good idea to set both the upper side to be white and the lower part to be white at the same time. Of course, it's not good, but we can see it if you want. Now we see everything is white. And you can change the right one to be something. This is kind of reverse of your lookup table. It's the same as you choose the preset of the lookup table as inverted. So we do have a inverted lookup table, which is essentially the inverted version of the default grayscale. So you see just the color switched. And it's the same idea or same concept for 3D lookup table. Let's say it again, the range for 3D is almost the same. The range, the lookup table, the opacity, 3 elements. For the range, the difference, well, there is some slight difference for the default settings. The default setting for 3D is, for example, this mode. When you open Dragonfly the first time, you probably see this settings. The color mapping is in the full range. So this is the same as 2D. The color could be mapped to the full range or to the window only. The second one is to the window only. But the default opacity setting is always 0 opacity for the left side. So everything below the left bar will be opaque or be transparent. Will have 0 opacity. This is the default setting. So for 2D, the default, if we go back to 2D, for 2D, the default is this is a full opacity for everywhere, and for 3D, the default setting is 0 opacity for the left side. And we have more options for the opacity for 3D. If we take a look, the second is the first one actually has only one like a bar, left bar. The right bar is not it's not changeable. You cannot change it at because it has always be the maximum of the data range. So the second one will be similar to what we have seen for 2D. You can change both bars. You can select your own range. But for the second one, it's not very clear. But you see the opacity is a very thin line here, which means the opacity for the right side, everything above the right bar has full opacity here. And the third one is a little bit different. Third one is for everything above has 0 opacity. So the difference is, I mean, the line here is very thin. It's not very clear, not easy to see. But you can see the difference when we render the images. Like when you would use this one, the second one, everything above is red. So you see red here, because they have higher intensity. But if you use the third one, you don't see, okay, you still see some red because it's in this, it's only in this part. You don't see this part. So for example, if you move here, so everything above will be transparent. And we also have the piecewise opacity settings. Like you can change this. It's the same as what we did for 2D images, 2D views. So you can change, you edit your control point for opacity. I think that's all I want to show today for this. I think if anything else I can. Yeah, for this is pretty well straightforward. That you see selected range is the range. The selector is the range of my window. So you see we can either drag the two bars, or we can input some specific number. For example, I want to say 14,000, so I can input here. The plot range is the range we plotted. We have plotted in this window, because we could zoom in and out this window by the mouse wheel. So when we move the mouse wheel, it will zoom in. Now, if we have a very small window, we can see this better. But so when we zoom in, the plotted range is not the full range of the data. So that's why we have this plotted range. And if we do reset, it will reset the plotted range to the full range. So again, the wheel will change. We'll zoom in or out, and we can left click can drag this histogram to make it go just to pan it, go to left or right. There's some other very practical tools here. This is for change the window level, not by dragging the bar or input the numbers here, but this will change by the mouse movement. So if I move up or down, let me make this smaller. Okay. So in this button, when this button is enabled, I can move my mouse up or down to change. You see, change the position of the window, not the width of the window. But if I move left, it will make it narrow. If I move right, it will make it wider. So this is a shortcut to change the window level without using any buttons, just your mouse. And this one, you can drag a square and it will use the intensity in this square for the best contrast. For example, if I want to see this crack, I just draw a small square here. So you see the window has been adjusted according to the intensity in this square for the best contrast. So I can see the cracker quickly. I don't have to try to move the window. And this is for reset. You set to the window is in the full range. So I think that's all about the rendering in 2D and 3D in Dragonfly. I'm going to check if any questions.
Yeah, there's a question there that I wanted to add.
Okay.
About the question in the chat is about what is the gamma at the bottom there below opacity, and second question, what is the global opacity compared to this opacity?
Okay, well, that's good questions. I think I can try to show it. The gamma is when we see, for example, this one, the gamma is a global change for the alpha. Alpha is the opacity, right? But the gamma is kind of, you see very clearly here, just to make the curve to have some other shape. Well, of course you can do this manually, but it's not as fast as we can do with the gamma. So this will, for example, this will give less opacity for the lower intensity part. So the more opacity for the higher intensity. So it's not linear, but with some kind of emphasize for lower part or higher part. The second is about the global volume. Yes, this is the global volume opacity. We use this only when we have multiple like objects to render. For example, I can go back to the grayscale, the default one, because I have not shown anything about the segmentation. So I do have a segmentation made for this dataset. If I turn this on, now the color we see here in 2D views, they are not the color from the lookup table anymore because I'm using a grayscale lookup table, right? So everything is black or white. It's a grayscale. The color now is from the segmentation. And I could also show the color in 3D. So again, the color is from the documentation from my multi-ROI. And now if I change the global volume opacity to be 0, which means I don't see the image itself. I see only the segmentation. Sometimes we do want this because we want a clear view of the segmentation. And I don't want to see any intensity, the original image intensity. So there are two different ways for this is more volume rendering. So see here now I turn it off the multi-ROI, the segmentation. We see everything here is from the volume, the image itself, the intensity of the image. And if I do this, of course, I don't see nothing if I put the opacity to be 0. And also it's a way to show transparent if I want to see something like transparent effect. Okay, I don't get. Okay, I think I have some to show, which is better, which is good to know. I have maybe 5 minutes for this session. I will do it very quickly. So you see, this is multi-ROI for multiple organs. I will, for example, I will extract the kernel of the walnut as one ROI. I could show this is my, it's not the best color for walnut kernel. But you see, I see only the the kernel of the walnut. If I put this back, you see this is the volume. I could, this is kind of transparent effect. Of course, I could use mesh for some other rendering effect. Without using mesh, I still can do many things. For example, I could show the image, like this is full image, full opacity for the image. But I could, when I select the ROI, I could say I want to show wait a second. Oh, okay. Yeah, this is something like I want to show my image, but only in the ROI, only the images in the ROI. So I set my ROI, which is here. uh, When I render my ROI, I show the label data to the maximum. So I show everything in the ROI with the intensity, which is the data. But I put the global intent opacity to be 0, so I don't see everything else. The good thing about this is we still can use lookup table to show different colors if we want. So I go back to uh, window levels, which is here. See, I can use some other lookup table to show colors. Not the best. Yeah, something like this. So it shows only the ROI, but with the intensity information also, because I'm showing